All right. Good evening. Thanks for joining Srinivasa, and I hope more people will join soon. Uh, so today, what we are going to do is we are going to, yeah, as you all know, this is a week two session, problem doubt solving session, and we will be focusing on week two contents, which will be problem mostly nonlinear equations. So in week two, we studied nonlinear equations and system of nonlinear equation. How do we solve them, right? So this is the main thing that we studied in week two. Uh, Today we will first I will do a recap of nonlinear equations. What are the methods that we studied, and later we will get into the today's problems and we will solve two problems. Uh, and some I will leave it to you, or leave it to you to solve them. Uh, before I start, if you have any questions, please feel free to ask. Uh, in the meantime, I will check whether my recordings are going okay. Yeah, and I also hope that you guys received an email from NPTEL regarding the recordings. You can now access it from uh, the dashboard, NPTEL dashboard that you have for this course. All right. If there are no questions, again, feel free to stop me anywhere in between and ask any questions if you have. Uh, we will move forward with today's topic. So, as I said, we discussed about nonlinear equations, and we know what are nonlinear equations, I hope. So, nonlinear equations will have like one or two dependent variables in either multiply, or if there are non-algebraic functions, something like trigonometry, exponential, hyperbolic. So if there are any functions of this kind is present in your equation, then that equation is called nonlinear equation. Um, so here they have explained it in a more general terms, like variables having an exponent either greater than 1 or less than 1. If it is equal to 1, then it becomes a linear equation. Okay. And the product of variables in an equation, if you see some product of variables in an equation, then also it is a nonlinear equation. And root is something what we call, if f of x is the nonlinear equation, whenever that becomes 0, the corresponding value of x is what we call it as root. Okay. And there are transcendental functions are nothing but a short form for, or the other word for non-algebraic functions. And then we also saw isolated rules and convergence. I mean, you can understand, like, this is an iterative method. So every iteration you want your solution to converge close to the original solution. So if uh, if it converges quickly, then its order is more. In that way, you can formally define this as order of convergence to be something like this, where the error in the present iteration compared to the error in the previous iteration reduces by an order p. Okay. So please note that it is in the power, right? So this p is the order of convergence. So we can evaluate each and every method which we will be using to solve nonlinear equation uh, based on this order of convergence, whether the method is converging faster or slower. So in that way, first method that we saw was bisection method, and there is something called intermediate value theorem, telling it does look like an obvious thing, but you know it just puts the simple things in perspective. So if a function varies something like this, and if your x value is between a and b, and corresponding the function value between fa and fb, then if you are seeking for a value c, the corresponding f of c will also will be in the uh, will be within the limits of fa and fb. So that is what this says, and we will be using this. This is the main theorem that is behind this bisection method. So only thing is, the value c that we seek is a root, and the k is actually 0. That's the uh, that's the difference between this theorem and the bisection method that we do. So the algorithm goes something like this. So we have an initial interval given and the function varies within that interval, and within that interval there exists a root in between. So only if there is a root in between, then only you can use this method. In fact, yeah, you should choose the interval in such a way the root is present in between that interval. So in this case, the initial interval is a naught and b naught, and what you do is you perform some iterations, try to reduce this interval to a very small value, and then you will be able to find a root. So how are you going to do is used to find midpoint. So midpoint between these two a naught and b naught you're going to find, and check whether that is a root. If not, whether the root lies in between a and c or in between c and b is what you're going to say. Whether the root lies in between this or in between this. Based on that, you update your interval again. Again, you continue these two steps again and again until you reach the root. Okay. So that is the iterative method, the bisection method, and the convergence for it is, as you can see, this is the simplest method, and hence you expect the convergence to be slow. Uh, it does not, uh, have a sense of how the function varies. For example, it just knows, okay, this is the interval somewhere in between I'm going to have, so I'm just going to move between in midpoints, right? Um, so the convergence is relatively slow to converge, and it always it is it is but it always converges. So that is one good thing about bisection. Whenever other method fails, people always tend to go to bisection and see whether you can find a root or not. Okay. Um, the next method is regular falsy method, which is nothing but same as bisection method, but instead of finding a midpoint, you will find a weighted average to find the next interval. So in that way, you are accelerating the process of reaching the root. So that is about regular falsy. So basically, by drawing a straight line and then trying to find out the point that is crossing the x-axis and checking whether the root lies between P1 and P2 and B or A and P2, and based on that you update the uh, you know your this thing. Now the secant method is similar to uh, okay, sorry, secant method is based on the line, but regular falsy is based on this average function. Okay, so secant method, as I said, you will draw a line and see where it cuts the axis, and you use now these three values to find where the root lies. Okay, so basically we will try to uh, you know uh, express this line. We will try to put an equation of line for this. We will express this as in terms of equation of line, and then we will equate this with the function, and then you will end up having something like this: Pn plus 1, Pn minus 1. So here you do not need to find the interval, you just need two initial guesses. So in this case, in this case, the initial guess is A and B. In between, the root lies. Okay, so this is how P0 and P1 should be your initial guesses, and from P2 you will use this equation to find subsequent uh, values until you converge it to the root. Okay, and the order of convergence is little higher than the uh, previous methods. Here the order of convergence is 1.6, which is better than actually bisection method. And then the most famous method is Newton-Raphson, and you will see everywhere Newton-Raphson is being used. Okay, even all the computers or any algorithms that you take for numerical methods, it will have Newton-Raphson in it. So it's the best, one of the best method, and also easiest method to implement. But it also comes with its own disadvantages. So basically, you use this as your iterative function to until you converge. And so convergence here means the previous iteration and the next iteration will almost give you the same result, and you will take that as a root. Okay, so that is the convergence, and this order of convergence is very large. It's usually 2, and uh, the problem with this is if your function if your derivative of function is 0, then you cannot find any convergence. So basically, if the f dash of xn is 0, what happens is this entire thing becomes, kind of infinity, and you will diverge the solution. And if you look at the, I mean, if you have gone through the lectures, you would have seen that why this is happening in terms of graphical way, right? So when the derivative of function becomes 0, it becomes a straight line, and it is parallel to x-axis, and you will never find that that tangent to meet the x-axis. So there is no way you will be able to reach that point. So that's why this whole thing becomes infinity, and hence your solution diverges. You can never find it. Yeah. So and if f of x has no real root, iterations may simply oscillate if it does not have a real root, which means it does not even it does not cut the x-axis, right? So then your iterations will oscillate. So in a way, this method will not tell whether the function has a root or not. It assumes that it has a root and it starts doing the iterations, but you might end up having oscillatory solutions and diverging solutions, right? But still, everywhere people still use it. It is the one of the best method. And fixed point iteration is a little more involved method. Basically, you will have a function, and you will construct another function with whose fixed point is actually the root of the function, right? The the function that we seek for, the root that we seek for the function. Now, this is how you write f of x is 0 and x is g of x, which means fixed point is, as I said, g of x equal to x is fixed point, and you can write in iteration you can write x of n plus 1 is g of x. So now you have to choose this function. We don't know this function. We only know f of x, which is given to us, but we have to choose this function. If we choose this function carefully, we will end up in Newton-Raphson method. But you can also choose a different function such that it converges to the solution. So that is also possible. So how do we end up with the Newton-Raphson method? So if you look at it, um, so Professor he explained it based on this, right? Maybe we will come to that later. We will go through this first. So basically, we need to choose g of x, and g of x should belong to a and b, and g of x should be continuous. So these are the criteria to choose the g of x, and also it should be differentiable. Um, if your function does not qualify for any of this, then you won't be able to get a solution. And also, this is also important, your derivative of that function within a and b should always be less than 1. Okay, only if that condition is satisfied, you will be able to use it as a iterative function in order to find the root. So this is what is being explained here, and I guess you guys must have gone through the lectures anyway. And these are all for one equation. If we use, then what if we have system of nonlinear equation? Usually we have system of linear equations, right? We express that in terms of ax equal to b, and we solve. That was our module 1, or week 1's problems. Now here we have system of nonlinear equations. Similarly, our functions will have two dependent variables multiplied together, or uh, dependent variables exponent will be greater than 1, or you can also have sine and cosine. We will solve one problem in system of nonlinear equations today to give you an idea. So basically, but here you cannot write it as ax equal to b. That is the difference. So if you could write it as ax equal to b, then it is problem is solved. You can solve using one of Gauss elimination, Gauss Jacobi, whatever we studied in the previous week. But here you cannot write it as ax equal to b. That is the main problem, and hence you need to follow one of the method. So the method is not any different. It's like applying the same Newton-Raphson method or fixed point iteration method to this problem. So you can even try to construct a bisection method for this. That is also possible. Only problem is you will have multiple x's, and hence you need to find what is the possible solution space between them. Okay, so here we focus only on Newton-Raphson method, and also there is no point in doing bisection because it just takes a lot of time to converge. So people always prefer for Newton-Raphson method, and these kinds of the where you will find this is whenever you have you know set of nonlinear equations. For example, your equations of motion, uh, let's say in robotics. Okay, um, your equations of motion will be in 3 dimensions and also will have 3 rotations, so you have 6 degrees of freedom. So you will have 6 equations of motion, and all these equations of motion will have non-linearity in it. Okay, it will not be linear. Hence uh, you cannot solve it using ax equal to b or using that. You have to use Newton-Raphson method. So that is the thing. Also, this Jacobian matrix has some significance. You will find it soon in multiple in coming weeks. Uh, and yeah, so basically in Newton-Raphson, uh, what you will do is this. It's just a derivative function for. Uh, 1 second. I hope I am clear now. Is it today's notes? Yeah, today's notes also will be uploaded in the drive, and yeah, I hope my voice is clear now. So basically, in the Newton-Raphson method, what we do is we write f of x to be f of x plus delta x, and then this is a Taylor series expression for a vector of variables. So you basically your function is multiple nonlinear equations, and x is basically the dependent variables that you're trying to solve, or the roots that you seek for. And the Taylor series, you can write it as a in Taylor series expansion. Remember, these are all vectors. Okay, and hence if you do that, then this should be a matrix, and this is the dot product. Okay, so uh, this matrix is what we call it as Jacobian matrix, and you just rearrange them to get the Newton-Raphson method, which is xn plus 1 equal to xn minus. Usually we divided by f dash of xn, right? So here this part is nothing but this f dash is your Jacobian matrix, and that comes with an inverse, okay, which is pre-multiplied. Okay, um, so this is your Newton-Raphson method. This is your way to iterate. So you just you use the newer for xn plus 1, you update the previous xn, and then again you just solve this for each and every iteration. You will end up converging your solution to uh, the root. Okay, so now what also shown is you can also the fixed point iteration, the Newton-Raphson is nothing but a special case of fixed point iteration. So if you use the best possible g, um, or best choice of g that would give you a better results, you will converge your fixed point iteration method to the Newton-Raphson method, and this is the derivation for it. And if you are interested, you please take a look at the lectures. I hope you guys have already done it. Okay, so this is what we studied. Basically, we studied how to solve nonlinear equations and the system of nonlinear equation based on these methods, right? So what we do is we will first try to solve this one nonlinear equation using 3 methods and see how this varies, or how much iteration does it take, and uh, you know how to perform such an iteration. Okay, I hope there are no questions till now. If there are any questions, please let me know. So the first question that we are solving today is uh, again a nonlinear equation, and an interval is given, and we should be solving in terms of 3 methods: bisection, secant, and Newton-Raphson method. Okay, first we will solve using a bisection method. So let me write down the function. F of x is e power x minus 2x squared. So we want the root of this function, root, which means f of, let's say, uh, what should I call it? Let's say I call it zeta is equal to 0. We want this zeta. Okay. So now the interval is given a and b. A and b is 1 and 2, I guess. Yeah, 1 and 2. So how do we perform? First we need to check whether the root lies in between or not. And how do we do that? First we will find f of a and f of b. Okay, maybe I'll write it down separate. So it means e power a minus 2 into a square, which is basically e power 1 minus 2 into 1 square, or e minus 2. And this is e power b minus 2 into b square, which is e2 minus 2 into 2 square, e power 2 minus 8. How much does these two comes out to be? So e minus 2, I think it will be somewhere like 1.353. Please check whether these numbers are right. This will be minus 0.6109. Okay. So now your fa and function, the function evaluated at point A is positive and function evaluated at point B is negative. So which means the function has moved from positive to negative, which means that it has crossed the x-axis. So what does it mean? It means between A and B you have a root. So in more general ways, what you can say is f of A times f of B is less than 0, which means root lies between A and B, right? A and B. So since we know root lies between A and B, and we are going to do bisection, so we will find the midpoint between A and B, and the midpoint is going to be, so that will be our first iteration. Midpoint C is going to be A plus B by 2. In our case, it's 1 plus 2 by 2, which is 3 by 2, which is 1.5. Okay. Now, let me write down. This is our first iteration. So you can go forward with first iteration only if f of a and f of b, I mean f of a times f of b is less than 0. Now, once you find c, you will evaluate the function at c and see whether it becomes 0 or not. So f of c becomes e power 1.5 minus 2 into 1.5 square. How much would this come out to be? Calculator. So 1.5 minus 2 into 1.5 square. So this is somewhere around 0.0183. Okay. So if you guys also have calculators, please do some calculations and let me know the answers. So f of c is 0.0183 and it is negative. Sorry, it is negative. So let me write that down. So f of a is 0.1353 and f of c, which is midpoint, minus 0.0183, and f of b is minus 0.6109. So now you can see the root is going to lie between these two because this is positive and that is negative. So which means f of a times f of c is less than 0. So root lies in A comma C. Okay, so you update interval. So how do I update interval? I will just say A to be 1, right? A to be 1, and now I will change the B to be C, which is 1.5. Okay, this marks the completion of our first interval. I mean first iteration. And in the second iteration, again you do the same thing. C is going to be A plus B by 2, which is 1 plus 1.5 by 2, which is 2.5 by 2, which will be 1.25. Right? So you guys understand? So since your function is changing from positive to negative between A and C, root lies between A and C. And if that is the case, you change the interval, keeping A to be as same as A and C to be B. Okay. If it is between C and B, what you will do? You will make A to be C and B to remain C only. Okay. So E value should be taken by 2.7182. Yes, 2.7182 you can take. Or if you have the calculator with E in it, you can just use them. All right. Anyway, in your exams also there will be calculators and it will have exponential function in it. So you no need to worry. So if you have a scientific calculator with you, if you have E in it, then you can use it. Okay. So now you found another midpoint f of C. So now you find f of C. F of C should be e power 1.25 minus 2 into 1.25 square. So now if you calculate E in terms of 1.25 minus 2 into 1.25 square, so that comes out to be 0.3653. Okay. So now again you compare this with f of A. F of A, what was A? A is 1 and f of A we already found, which was 0.1353, and f of C is a midpoint between them, which is 0.3653, and f of B is basically the previous f of C, which is minus 0.0183. So which means you can kind of understand that if you look at it, so one is f, so f of 1 is at 0.13 and f of C is like minus 0.0183. So which means root is actually lying much closer to 1.5 than 1.25, right? So ideally I should have taken some other like instead of blindly following bisection method, if you want to update it and if you want to use it, f of C is yeah, it was 0.0183 in the previous iteration. Now in the second iteration you have updated the C to be 1.25, right? Well, if you update your C to be 1.25, it's 0.3653. Okay. So as I was saying, what you found is the midpoint is somewhere closer to 0.0183, and this corresponds to 1.5. So which means your value is going to be somewhere near 1.5. So ideally it is useless to calculate what is going to be 1.25 or what is going to be 1.375 or whatever it is. So that is not going to tell us anything. So maybe I will do one more iteration so you guys will understand what is my point. So what this tells us, C is positive and B is negative, which means root lies in between them. So f of C, f of B is less than 0, which means root lies in C and B. C is 1.25 and this is 1.5. Correct? Yeah. So now your third iteration would be, how would be your third iteration? For third iteration, you will take A to be 1.25 and B to be 1.5, and hence C will be A plus B by 2. Okay, and 1.25 plus 1.5 divided by 2, this is going to be something like 1.375. Okay, now f of C you can find out. F of C is e power 1.375 minus 2 into 1.375 whole square, which is going to be, I guess, around 0.1738. Okay, now again you can check for yourself. F of A, which is f of 1.25, which we found out to be 0.3653 from the previous iteration, and f of C is somewhere now we found out to be 0.1738, and f of B is going to be minus 0.018. Okay, now again you find out that between C and B is where your solution is. Okay, so root lies between C and B, where C is, what is C? 1.375 and B is 1.5. So as I was telling, in the first iteration itself we can get some idea from here. So you see, in the first iteration you have A is 1, this is 1.5 and this is 2, right? Now you see A is positive quantity, which is 0.13, and 1.5 is in the second decimal, you have some number, and similarly at 2 it's in the first decimal, right? Which means somewhere around f of C, not in 1 or 2, you don't need to have that big interval. Somewhere nearby 0.5, 1.5, you are going to have uh, root. But the problem with bisection is, even if you understand that, you have to follow the method, and you have to keep oscillating between the midpoint. And but that is not the case with respect to other methods, right? So Harini, do you have any questions? So actually you guys no need to raise hand. You can just unmute yourself and ask your question. It's fine. You can stop me. Okay, I hope Aruni doesn't have any questions. If not, please unmute yourself. So, um, yeah. So basically, we can continue this, or we can do something interesting. Um, so this is third iteration. We haven't yet found out what is the real value, right? So what I will do is, um, maybe instead of doing this continuously, I will show you a small MATLAB script in which we can solve this problem very easily. Okay, just give me a couple of minutes. Okay, let me present. Okay, I hope you guys can see my screen. Yeah, so I think you guys can see my screen. So this is like a MATLAB script. I'm not sure whether you guys are aware of. You can also do Python, but I'm just going to show you an algorithm. So for example, let's first try bisection method. Okay. So clear is just for clearing everything. nothing much in it. So what we know is the function is, we know the interval a is 1, okay, and b is 2, and we know function is nothing but your exponential of x minus 2 times x square, right? This is your function. I hope everyone can see, right? Yeah, and let me check my recordings also. Okay. So this is your function. In MATLAB, what we usually do is, if you have a function, you just write it as a function handle, so that you can always send this x and evaluate the function again and again. Okay. Now the iteration is I. So initially, let's just make it first iteration. So, and we, let's say, first thing we want to do is we will find midpoint, right? C is a plus b by 2. Let me find that a plus b by 2. So once you find c, let's just try to find the function f of c. Let me call it fc. So here this is the variable, and you are trying to do something here and assign it to the variable. Okay, that's the thing about this MATLAB. It's very simple, you can easily learn about it. Okay, so fc is what you will write, exponential of c minus 2 times c square. Okay, now what you have to do, you have to check whether you can use a if condition, if f of if but for that you need to find a, right? So first thing is to find whether root lies between a and b. So before we do any of this, you have to find. Does anyone have any doubts? Okay, I hope there are no doubts. If so, please let me know. So first thing is, we need to find whether root lies between a and b, right? So if the root lies between a and b, or first we need to find out whether the root lies between a and b. F of a is exponential of a minus 2 times a square, right? And similarly, f of b is again exponential of b minus 2 times b square. Okay, so for now let me remove this, it's a little bit advanced concept. So first we will find fa and fb, and check whether if fa times fb, sorry, fa times fb is less than 0, right? If it is less than 0, then what do you do? You start finding c, which is a plus b by 2, right? And if that is the case, then you will find f of c, right? And after that, you will find whether c is between uh, whether c is a root, or whether the root lies between a and c or b and c, right? So this is where you will find, this is what you will do first. Okay, so first let me just save it somewhere, bisection. So let's say if I go and run this, so I can basically see your c is 1.5, and you can also see f of c, which is 0.0183, same as what we got. Now what we have to do is we have to do the second iteration. So for that iteration, which means we have to keep repeating these steps again and again, right? So for that, what we will do, we will put them inside a while loop. So this is the iteration number, this, let's say, iteration. Okay, and we need to put it inside a loop, and you can either use while loop or for loop, whatever you want. I'm going to use while less than 100. Let's say I want to maximum use only 100 iterations. So I will just put this entire thing inside the loop. Okay. Now, once you will do this, you will find the midpoint. Okay, that is the second step. We find midpoint. So once you find midpoint, what you will do, you will find where the root lies, right? To find where the root lies between A and C or B and C. This is what your next objective is, right? So to do that, what you will do, you will find if you will find f of fa times fc, correct? Whether this is less than 0 or not, you will check first, right? So let me enclose that um, inside a bracket and write it in terms of if condition. Okay, if fa and fc is less than 0, what I should do, I should just make so then root lies between a and c. So what I will do, I will write a to be a I will not change a, which means a is equal to a. I no need to really do this, but just for your understanding, I will do this. And b is going to be what b is going to be? B is going to be c. Correct? It's just the swapping of things that we do in classic computer problem. If not, if that is not the case, you write a else. You tell that then root lies between B and C. If that is the case, then you change the A to be B, sorry, A to be C, and B you keep it as B, right? That's all. So once you change this, what will happen? At this, it will end, and then it will go back again here. Let me drag down. So it understands, okay, the A and B you will change here, and then it comes back here, and then it will again find FA and FB. You can optimize a bit because you already found FA and FB. You no need to really find this again, but for the sake of completeness, I have written. You again find FA and FB, again find midpoint, again update the interval. Okay, so let's see how this performs. So in order to how things vary between the iteration, let me just write a print statement. Here the print statement is in terms of disp is the uh, way that you can print. You can also use printf for something, that is, so those things you can check for yourself. So I can write it as iteration. Let me just write it as iteration I. Then I want to know what is the interval. So let me write it as a, and so this is just a printing thing. You no need to worry about this. B. Okay. So this is just for printing. This 32 line is just for printing. No need to worry about this. So basically, I'm also trying to write iterations. I mean, I'm trying to identify which iteration and what is the interval does it correspond to. What the interval it reduced to. Okay. So let's try to run this function and see what happens. Okay. Yeah. So you can see here now it has converged to some value, but one more thing we forgot to do is we found iteration, we made I to be less than 100, but we didn't update the I, right? So we can write I equal to I plus 1 here. Okay. Okay. Now let's run this. What happened? Okay. None to. So the problem is it always consider things as a string. So you need to convert the number to string in order to show. Anyway, so now you run this, you will see here I have run for like 100 iterations. So initially it started with, okay, let me run it again. So we started with 1 and 1.5. Our second iteration was 1.25 and 1.5. Third iteration was 1.375 and 1.5. Similarly, this is where we stopped, and we could have kept on doing it, but it will just take a lot of time for us. So I went on with I went on with this MATLAB program. So the fourth iteration becomes something like this. Fifth iteration will this, so you can see this interval keeps on reducing. So here it was like 1.25 interval, and now it keeps on reducing, and at some point you would see like it has converged to a very low value, so 1.488. So if you, let's say, um, let me go back to the uh, this thing, stop sharing. So what we did was we did a MATLAB program, and then uh, so around iteration number, let's say somewhere around 16, around iteration 16, we could have continued this by hand, but it's just, boring task. So around iteration 16, we found the interval to be like 1.488 and some numbers, and 1.488 and some numbers. So up to the third decimal, if you want, the root is going to be 1.488. Okay. So in exams, you will not be asked to do any program, or you will not be asked to do a lot of iterations. You will be asked like 1 or 2 iterations you do, and then show us what is the interval you have reduced to. So I think one of your assignment is also something like that. But in order to give you a full picture, so around iteration 16, it will converge to a root of 1.488, and we can understand that because 1.5 gave minus 0.018, right? And hence we expect the root to be somewhere nearby 1.5, and hence you also have 1.488, right? So this is how um, you know, I mean, you can write these MATLAB programs. The one I wrote is very simple version. You can optimize it however you want. So you can do some MATLAB programming, or you can also do Python programming to do this. Okay, it's a good idea if you do it, because it will also improve your uh, understanding with this subject. But it is not necessary in terms of you know uh, in terms of your exams and assignments. Okay, so from bisection method, it will take like 16 iterations to converge, and that is the first part of our problem, and the root is somewhere around 1.488. Okay, so I hope you guys understand bisection method. We will so here there are few questions. So please create WhatsApp group and share PDF notes of Sunday class into WhatsApp group. How to get your notes? Okay. So what I would suggest is I will show you how to get the PDF notes. You try to use that method, and if not, you let me know. I can email also. Okay. So I will show you how to get it maybe by the end of the class, and yeah, so the same question. Okay, and the please explain fixed point functions. Okay, yeah, we will do that. Maybe after solving the other two problems, we will do that. Okay, so I hope there is no problem with bisection method. You guys were able to follow. Now the second method is secant method. Secant method is again straightforward. uh, we already know the function values p, and we already know the iterative function what we should do, right? So it's pn plus 1 equal to pn minus 1 minus f of pn minus 1 times pn minus pn minus 1 divided by f of pn minus f of p n minus 1. Okay, so basically we know that p naught and p1, which is 1 and which is 2, or a and b. Now from here you go forward. We know between a and b the root lies. So from here you go forward and find p of 2, p of 3, p of 4, p of 5 until two consecutive p's match. Okay, so let's do that. Let's find out p of 2. P of 2 is p of 0 minus f of p of 0. So basically I'm going to put n is equal to 1 because iteration is 1. P of 0 into p0 minus, sorry, p1 minus p0 divided by f of p1 minus f of p0. Okay, now you substitute these numbers here. It becomes a, which is 1 minus f of 1. What is f of 1? We found out in the bisection method, or you can also find out f of p naught is 0.1353 and f of p1 is minus 0.6109. Okay, that was our previous values, right? So we already found it. I'm just going to use it here. We will see how much iteration it takes to converge. So now you can write this 1.353 times p1, which is 2 minus 1 divided by minus 0.6109 minus 0.1353. Correct? So now you perform this calculation, it would come somewhere around 1.1813. Okay, this is your p2. Let's calculate f of p2 also, because that is going to be used in our next iteration. F of p2 is e power 1.1813 minus 2 into 1.1813 whole square, which is around 0.4677. Okay, now let's go to second iteration. N is equal to 2. So for that you write p3 is equal to p2, or I think it's p1. p1 minus p1 into f of p1 into p3 minus p2. Correct? So p2 minus p1. We haven't found p3. And f of p2 minus f of p1. Now you can substitute these values here. 1, I think p1 is 2 minus f of p1 is minus 0.6109 into 2 minus 1 is 1.1813 minus 2 divided by f of p2, which is 0.4677 minus f of p1 minus 0.6109. Okay, now you can do this calculation and it will come somewhere around 1.5363. You can also replace, so whatever the while loop that we wrote in MATLAB, inside that you can replace that a b c calculation with just this one equation. Okay, and if you just run it, it will, for every iteration it just quickly shows you. You don't need to do this and calculation, but for the sake of completeness I'm showing it. And you know, so f of p3 is going to be e power 1.5363 minus 1.5363 whole square, and this comes out to be around minus 0.0731. Okay. All right, now let's go to the third iteration. You just need to find what is the p, and you need to find f of p in every iteration. That's all. In third iteration, p4 is going to be p3 minus f of p, sorry, I guess it's p2 minus f of p2 times p3 minus p2 divided by f of p3 minus f of p2. So what is this going to be? 1.1813 minus 0.4677, 1.5363 minus 1.1813 divided by minus 0.0731 minus 0.4677. Okay, so this gives P4 to be somewhere around 1.4883, and f of P4 is e power 1.4883 minus 2 times 1.4883 whole square. So now you calculate this, you will be surprised to see the function is 5 minus 0.0005. Yeah, this is your function, which means this is almost 0, which means this is your root. You can for if you want, you can do fourth iteration and you can find p5, and why don't you guys calculate it and find for yourself that the p5 will be somewhere again close to 1.4883. Okay, so within 4 iterations we were able to, by hand calculation, we were able to find the root, but that is not really the case with bisection. Okay, and you will be surprised to see, I'm not going to do Newton-Raphson. So for Newton-Raphson, what you have to do, Newton-Raphson. So I will do a Newton-Raphson for system of equations. So I will leave this to you to solve. So in Newton-Raphson, you will have xn plus 1 equal to xn minus f of xn divided by f dash of xn. So in secant method, you have this p, right? Here you will have this. You will have to find function. You will also have to find derivative of that function, and then you use this equation to find the new iterative value, and then again you find the function and its derivative evaluated at that new value. Again you update them. So that is how the iteration for Newton-Raphson works. So I will leave it to you guys and find out how many iterations it will take to converge. Okay, so this is something you can do, and so you can see that, like, out of like around 4 iterations the secant method took, and hence you would expect Newton-Raphson to predict it in 2 or 3 iterations. Okay, and for that you need to find a actually the number of iterations it will take depends upon the initial guess value. Depends on x naught. So in secant method we use both the intervals, right? Here you have to have only one. So let's say you take x naught to be equal to 1, okay, and then you start your iterations, or you take x naught to be equal to 1.5 and then you start your iterations. So whenever you have, since x naught equal to 1.5 is closer to 1.488, 488 is your result, so you will have you will take only less iterations to converge to 1.488. But that's not the case when you start from 1. Okay, although in this it may not have that much difference, but you will see for yourself how much time, how much iterations that this method takes. Okay, I hope it is clear till now. If there are any questions, please let me know. Now we will solve a system of nonlinear equations. Okay, till now we solved only one equation. Now we will solve system of nonlinear equation. For simplicity, I'm going to have only two nonlinear equation. So in this case, let's say I will call f1 is y square minus x cube, and f2 is cos of y minus x. Okay, and I'm going to call let's say, what should I call? Um, so let me write this. That's x naught y naught. Okay, so I'm going to call x1 to be x and x2 to be y. Okay, just for convenience. So what you can do, we can actually write a vector x which has x1 and x2. Okay, which is basically x and y, which is your dependent variable whose roots you want to find out. And you can also have a function vector which has f1 and f2, which is basically y square minus x cube and cos of y minus x. Okay, so this is how you write the equation in terms of vector form. Now let's try solving this using Newton-Raphson method. So in Newton-Raphson, what do we do? X of n plus 1, I'm going to write iteration as a superscript, x of n minus function evaluated for nth x and its derivative. Okay, this is our Newton-Raphson method. In general, that's how we write. But since this is a matrix, what we have to do, we will write this in terms of, this becomes a Jacobian inverse, and then since it's a vector, you will write this as capital F x of n. Okay, this is your Newton-Raphson iterative function. You just apply it every time. But for this, you need to find the Jacobian matrix. The Jacobian matrix, how do you find? So the Jacobian matrix is nothing but dou f1 by dou x1, dou f1 by dou x2, dou f2 by dou x1, and dou f2 by dou x2. Okay, so basically what I'm trying to say is f will remain constant along the row and x will remain constant along the column, or in other words you can write I is the row and j is the column. So dou f5 by dou xj, I is row and j is column. So this is how you write the Jacobian matrix, and we know the functional form, so we can find dou f1 by dou x. Dou f1 by dou x1, what will happen? So it's y square minus 3x cube. So it will be minus 3x square, right? Or maybe I will just directly write it in the Jacobian matrix. So j of x is going to be this will be minus 3x square. Okay, and similarly if you want to differentiate this with respect to x2, which is y, this becomes plus 2y, plus 2y. Now dou f2 by dou x1, um, this function has only one x here, which is a minus x, so this, if you differentiate it, it becomes minus 1. And similarly you have cos of y here, cos of y here, and if you differentiate it, then it becomes minus sine y. Okay, now remember, you should not multiply the Jacobian matrix here. You should take the inverse of the Jacobian matrix and then you should multiply. Okay, so I will do one iteration with this. The remaining iteration, you guys do it and converge it to x and y. You can either use MATLAB or you can use you know, you can do by hand, but it will take a lot of time. So now to find the Jacobian matrix inverse, you can, one thing is, since you have a simple explicit form of Jacobian matrix, you can easily invert it. You can write the entire Jacobian matrix in terms of equation, and then you invert them. Inverting also should be fine with the functional form that we have here, and you can substitute in this method, or you substitute the x values and y values, you get the Jacobian matrix in terms of numerical values and invert them and then multiply. So you can do either way. Okay, now what I will do is, since it's a numerical method, we will substitute all the values and then we will find the inverse. Okay, so j of x, let's say x naught. Okay, first let me define x naught. X naught is x naught and y naught, which is given in the problem. So I have asked to take initial condition to be 0.8 and 0.7. So let's write this down, 0.8, 0.7. So now you can write the Jacobian matrix in terms of x naught, which becomes minus 3x naught square, 2y naught minus 1 minus sine of y naught. So remember, while using calculators, you may need to use radians here. You cannot use degrees. So if you do that for sine wave functions, you will end up having wrong results. Okay, just a heads up. So if this is the case, let me just replace that with the values. 0.8 square into 0.7 into 0.7. Okay, now if you find the Jacobian here, it is going to be something like do I have it? Yeah, it is 1.92, 1.4 minus 1 and minus 0.6442. Okay, this is your Jacobian matrix. Now you need to find the inverse of this Jacobian matrix. Since it's a 2 cross 2 matrix, you can easily find it out. Inverse is going to be 1 by determinant of Jacobian matrix times minus 0.6442, 1.4, minus 1.4, 1 minus 1.9. Okay, we also need to find determinant. Now, determinant of Jacobian matrix is minus 1.92 times 0 minus into minus plus 0.6442 minus of 1.4 into minus 1. Okay, so this will come something around 0. How much is this coming out to be? 1.92, 0.6442 minus plus 1.4. This comes out to be 2.6369. Okay, and So now let's find out the Jacobian matrix inverse, which is 1 divided by 2.6369 minus 0.6442 minus 1.4, 1 minus 1.9. Okay, so if you substitute them, this becomes minus 0.2443, 0.5309, 0.3792 minus 0.7281. Okay, this is your Jacobian matrix evaluated at the initial iteration. So now we need to substitute in the n plus 1. So n is 1 here, right? So x first iteration is going to be this is, for this you make it n0, but it is first iteration. Okay, x of 0 minus Jacobian evaluated at x of 0 times function evaluated at x of 0. Okay, so x of 0 we know, which is going to be 0.8 and 0.7, minus Jacobian inverse we just found, minus 2443 minus 0.5309, 0.3792 minus 0.7281 times the function evaluated at x naught. That we didn't do. Maybe I will do it here. What is the function? Where is the function? Y square minus x cube and cos y minus x. So y square is, what is y? Y square minus x cube, 0.8 cube, and cos of y minus x 0.8. Okay, now you perform this thing. Maybe I will simplify it a bit. So this becomes 0.7 square minus 0.8 cube is 0.022, and this is minus 0.03516. Okay, so this is the matrix multiplication. These two are matrix multiplication, and this will give you 2 cross 2 times 2 cross 1 will give you 2 cross 1, right? And then it will be a vector, and you can subtract these two vectors to get the first iteration value. So here I'm going to write it down, the solution for you guys. This is going to be 0.7716, and this is 0.6827. Okay, this is your first iteration value. And in fact, you can continue this. Once you find the first iteration, you again find so what we will do, let me just write it down. For the second iteration, first is find the Jacobian matrix J of x1. Okay, and then invert the Jacobian matrix, invert to get J of x1 inverse, and then find the function value f of x1, and then substitute them in x of 2 minus x of 2 is equal to x of 1 minus Jacobian of x of 1 inverse times function of x of 1. Okay, you can continue doing this, and then uh, this is for second iteration. Similarly, you can, once you find x of 2, you can do it for third iteration, and you keep doing this, and you will eventually uh, find the solution. So for maybe, for example, I will show you uh, MATLAB code written for this. Okay, all right. So this is the bisection code that we wrote. Similarly, there is also a different Robson method. So what I did here is I have xn is now for n equal to 0, it becomes x naught, and then I have function and the Jacobian matrix written in the functional form. So the in Newton-Raphson it becomes very simple like this. So you find the new x with the old x minus inverse of Jacobian matrix multiplied by the function evaluated at the Jacobian matrix. When you put this handle at x, then it becomes a function handle. You can call this function any time to evaluate these values, and this will return the vectors. Okay. So now if you run them, you will find that. So I think what what was our initial condition? It's 0.8 and 0.7, right? And if you run that, so if you look at this here, within 3 iteration, so the first iteration value around this only we also got 0.7756 is what I'm getting here. It's sorry 0.776. We also got 0.776, and the y value is 0.68274, but that is pretty equal to the pretty much close to the real roots of this function, of these two nonlinear function. Now if I change this initial condition, so this is the initial condition, so now let's say if I departed from here, let's say some 1, and I'm going to give this 2, for example. Now it takes 5 iterations. You can see previously it was just 3 iterations. Now it takes 5 iterations to converge. So based on where you start, it will be different. For example, if I depart from 2 to 2, then it goes till 6 iterations to converge. Okay. So this is basically the idea. So you can write the similar thing for this is for 2 cross 2 matrix. Similarly, you can do for 3 cross 3 or n cross 1. But only thing is this is costlier. The inverse of finding inverse of Jacobian is costly in terms of numerical uh, algorithm. But there is no other way. For Newton-Raphson, we have to find the Jacobian matrix. Okay. I will also attach this code snippets for you guys to try it out. You can also edit them and change it for your uh, change it for different algorithm. Okay, just for fun. One second. Let me switch back to the iPad. All right. So this is how you solve the system of nonlinear equation with the Newton-Raphson method. Okay. So only thing is we need to find Jacobian matrix, and Jacobian matrix is nothing but your derivative, functional derivatives. Okay. Let's check whether there are any questions here. So please send week 1 and week 2 PDF notes by email. Okay. Let me show you how to get it. So everyone seems to be asking the same question. If you get to the NPTEL, I have also registered. So if you go to the course, this will be your welcome page, right? So here you have this problem solving session, July 2025. So here you have both recordings. If you open the recording, it will show you a link here. There is a click here button. and if you click this, it will open you to this page. Okay, in this page you can find the YouTube link, and also you can find the drive link. Let me open the link. So you will find the week one, like uh, uh, week one notes here. Okay, the entire notes is here. Similarly, I will upload in the same drive. I will upload the week two now once our session is over, and then you can access them too from here. Okay, so this is in your NPTEL page where you find week 3, week 4 contents. There in quizzes, where you will take quizzes, that place itself you have problem solving sessions. Okay, all right, this is clear. Any questions regarding the methods that we saw today? And so Lakshmi wants me to explain about fixed point method.
Sir,
Yes, please go ahead. So in fixed point iteration, I do not have any. How do I show this to you? Just give me a minute. Maybe I will find a. I will find. I will find a problem. Just give me a minute. Explain. In the meantime, if you guys have any doubts, please let me know. Let me check this. Does quiz have fixed point iteration? Okay, so let me just solve this. Hopefully this works out. Fixed point method. Uh, solve x square minus 3x plus 2 equal to 0 using fixed point. using fixed point method. Okay. Um, so basically, what we have is we have a function. This is our nonlinear function x square minus 3x plus 2. So we need to find the root of it. So to find the root in the fixed point method, what we do is we first identify a function, iterative function g of x, such that the fixed point of g of x will be the root of f of x. So what does it mean? So what we do is identify a function g of x such that fixed point of g of x is the root of f of x. So which means what is fixed point? Fixed point is x is equal to g of x. So whenever the function value and the x value coincides, then that becomes the fixed point. Okay, f equal to g of x is the fixed point. So now in the fixed point iterative method, what we do, we first need to find out what is this g of x. So so we will take this function f of x, which is x square minus 3x plus 2 equal to 0. We just write it in terms of x. Okay, so how will you write it? Minus 3x is equal to, or plus 3x is equal to x square plus 2. X is equal to x square plus 2 by 3. Now you can write this as g of x, right? So now we have identified a g of x, which is x square plus 2 by 3. Okay, now the fixed point of this fixed point of g of x is root of f of x. So how am I saying this? Because fixed point of g of x satisfies x is equal to g of x, and which is nothing but your f of x. So this is how you got the g of x is, this is how you got the f of x. So now the fixed point iteration says that the x of n plus 1, the newest iteration, you can take it to be g of xn. Okay, that's all. So now you start with the iteration value, you find the g of xn, and
Sir, sir,
yes, yes.
sir, in terms of fixed point is given by g of x, then how to find f of x, sir?
You no need to find f of x. F of x is out of the picture now. Oh, okay. You mean to say if the g of x is given, how to find f of x? Is that your question?
Yes, sir.
So that is difficult to find, right? So if a f of x is given, there are multiple g of x. Similarly, for a given g of x, there is also multiple f of x. Okay. So for example, let's say, let me tell you. Let's say your g of x is, you take the same thing, x square plus 2 by 3. Okay, now fixed point is this g of x is equal to x. Okay, so you equate this equal to x, then it becomes x square plus 2 is equal to 3x, and x square minus 3x plus 2 equal to 0. This is the f of x. Okay, so for a given g of x, you can find, you just equate that to x and you find the f of x. Okay, but
Okay,
for a
sir.
given f
Okay.
of x, there could be multiple g of x. So for example, I can write g of x to be f of x minus x. Okay, or x times f of x. Okay, now if you equate g of x equal to x times f of x equal to x, then it becomes f of x minus 1 is equal to 0. So this is how you find, so this is also one of the g of x. Okay, so let me give you an example. So this is clear, right? Till now this is clear. This is how
Yes,
you will
sir.
find. Is that your question, first of all?
Yes, sir. That is only. But I have one doubt, sir.
Mm-hmm.
In a second week assignment,
Mm-hmm.
second question is there. A fixed point of the function
Mm-hmm.
g of x is equals to x bracket x minus 2 whole square plus 2
Correct. Mm.
is on.
Right, right.
What is the answer, sir?
Oh, that you need to find out. I cannot tell
Yes,
that.
sir.
So, what was the question anyway? Let me check the question.
Week 2, sir.
Uh,
Week 2, second question,
this
sir.
one, fixed point of a function is. So they are
Yes,
asking the
sir.
fixed point. You no need to find f of x. You need
Okay,
to
sir.
find fixed point of this function. You understand?
Yes, sir. Understand.
So you need to find fixed point. You no need to find f of x, which means you can simply do this iteration to find out. Okay. So for
Okay,
example,
sir.
let me solve this so you will get an idea. Um,
Okay.
so this is your g of x. Let's say your initial x naught is what should I be x naught? Let's say I take it as 1.5. Okay. So my x1 will be g of x naught. Okay, which is nothing but 1.5 square plus 2 divided by 3. So how much this comes out to be? 1.5 square plus 2 divided by 3. So this is 1.4167. Okay, this is my x1. Now x2 is g of x1. So you just put 1.4167 square plus 2 divided by 3. Okay, what this will give you? Square plus 2 divided by 3. 1.3356. Okay, now x3 is g of x2, which is 1.3356 square plus 2 by 3. So square plus 2 divided by 3, 1.2613. x4. I don't know when I will stop this. Let me try, give it a try, another 3 iteration. 1.2613 square plus 2 divided by 3 whole square plus 2 divided by 3, 1.1969 x5 g of x4, 1.1969 square plus 2 by 3 square plus 2, 1.1442 x6 g of x5, 1442 square plus 2 by 3 square plus 2 by 3, 1.103. I guess it is around 1. So x6 is 1.103 square plus 2 divided by 3. 1.072. x8 is square plus 2 by 3. 1.0499. x9 is square plus 2 by 3. 1.0341. And then x10 square plus 2 plus 2 by 3, 1.0231. And x11 plus 2 by 3, 1.0156. So you can keep doing this. Okay. 3, 1.01 plus 2 by 3, 1.007. I think it converges to 1. Okay, x infinity or whenever it is, it converges to 1. Okay, so the other way to find out is you go back. What is g of x? For this simple function, you can easily cross check. G of x is x square plus 2 by 3, and its fixed point is what you need to find out. So this is equal to x. So this gives your function, what is x square minus 3x plus 2 equal to 0. And you know how to factorize this. I think it's x minus 1, x minus 2 equal to 0, correct? And x is equal to 1 comma 2. So which means x is equal to 1 is one of the is the one of the root, right? So the root of f of x, this is f of x, this is f of x, and this is root of f of x. And what I said before, the root of f of x will be equal to fixed point of g of x. So the fixed point of g of x is this. Fixed point of g of x, which is equal to x square plus 2 by 3. The root of f of x is equal to x square minus 3x plus 2. So you can either ideally do this simple thing, or you can do this iteration. It will converge to 1 at the end of the time, at the end of the day, right? So until it, so currently it is like 1.007. If I continue to do this, 1.007 square plus 2 by 3, 1.004, 14th iteration, 15th, 16th, 17th, yeah, 18th, okay, 19th, okay, around 20th iteration, this will converge to 1. Okay, which is the fixed point of g of x, and that is exactly what they are. Give me a minute, sorry. I'm sorry about it. Okay, yeah, sorry about the disruption. So basically, um, the fixed point of g of x is what they are asking. You can do this iteration, you will eventually converge, or you transform your g of x to f of x. Since it's an quadratic equation, you can easily find the root of f of x, or you can use Newton-Raphson to find the root of f of x, and that will be your fixed point of g of x. Okay, is that clear? There are multiple ways to do this. I kind of easily explained you how to get the answer. So, but I hope you understand it. Is it clear how the fixed point iteration works, and what is the question asking for and what you need to answer? Mm, all right. I hope Lakshmi understands this.
Yes, sir. Yes.
Okay. All right. Any other questions you guys have? I think I have addressed all the questions in the chat today. Um, I don't think now I need to send an email to any of them because I just showed how to get the videos and notes. I will be uploading this note also as soon as this session is over. Okay. All right. If there are any questions, please do stay back and ask. If not, then we will meet in the next session. In the next session, we will talk about eigenvalues and eigenvectors, how to find them, and a few other problems that we solve. Okay. All right. Thanks for joining. Thanks. I think around 7 to 8
Sir,
people joined. Yeah. Thank you. Yes, Lakshmi,
sir,
please go ahead.
uh, once exam pattern is explained, sir.
Uh, Exam pattern you will get to know. It will be like your assignments. Like some uh, choose the best answer. Multiple choice
Okay.
questions you will have, and
Total how many questions, sir?
mm, I think you will get to know it sooner. So it will be same as your assignments. Okay,
Okay.
and some of
Okay.
them will have 2 marks, or some of them will have 1 marks. Okay,
In same question, sir?
yeah, for the same question, you will have either 1 mark or 2 marks. That is possible,
Okay.
depending upon the complexity of the problem.
Question.
Yeah.
Okay, sir. Thank you, sir.
All right. Thank you everyone for joining. If you have any questions, please stay back. If not, we will continue in the next week. Okay. All right. Section.